So in this lesson, we are going to discuss domain and range for functions. And before we introduce definitions for domain and range, we want to review the inequality symbols. So less than or equal to, greater than or equal to. So the opening is facing the larger number and the arrow is facing the smaller number. So before we have the equation, then we have equal sign. Equal sign means the left side is same as the right side. When we solve an equation 6x equals 30, we solve it, we have x equals 5, and it is x is exactly same as 5. But for inequality, equation is x less than 5, then it means x, any numbers that is less than 5, they are the solutions for this one. So for example, negative 1, 2, 1.7, 2 divided by 3, 0, they are infinite solutions. To show this, we can use a number line. So the 5, we circle 5 here, but using open circle. X less than 5 means all the numbers that on the left side of the file on the number line, they are the solutions. So we could write x less than 5. So these are the solutions. And we have the arrow at both and it means this one keeps going until the negative infinity. And keeps going to the right side, you will have positive infinity. So this solution for x less than 5 in the interval notation, we could write it as a minimum x to the minimum number is negative infinity, and the maximum number for this solution is 5. No equal sign, so we don't put equal sign there, and open dot means not equal to this number. And how about x less than or equal to 5? So 5 is not less than 5, but 5 is less than or equal to 5. It's correct. So x less than 5 and including 5. So this one, x less than or equal to 5 means x less than 5, but also equal to 5, including 5. If we draw the solutions for this one, it will be solid dot. Then to the left side. So this notation, the interval notation is a minimum, then maximum. We put a bracket there. This one doesn't include the 5. And for this one, write it as this way, minimum, then maximum. And for the interval notation, it will be negative infinity, and include 5 this time. We use squared bracket. So equal sign, we use squared bracket. So this one we call inequality notation. So this one we write minimum on the left side, maximum on the right side, then we put x between it. And the solid dot is equivalent with equal sign. Okay. And also it is, if you have equal sign, then we put solid dot or the bracket, square bracket. That will be the solid dot, include that number. So now we are going to see, we have inequality notation, we have interval notation, also we have number line notation. So for question 1, we want to write it as an interval notation. So this is a minimum, this is maximum, and for the interval notation, we just put the minimum, maximum in bracket. If no equal sign, it's just regular bracket. If you have equal sign, it's a squared bracket. So these two notations, they are equivalent. And on the number line, we draw a number line, so 1, 2, 3, and we know that for the squared bracket is solid dot. For the regular bracket is open dot. From 1 to 3, minimum to maximum, this is equivalent with x greater than 1, less than or equal to 3, the solutions for this inequality is from here to here. And for this question 2, the number line is given, so we want to write this out. Will be, we find the minimum, we find the maximum, then we write minimum, maximum, then put in bracket. So this one open dot will be just regular bracket. For infinity, we don't use squared bracket because you will never ever reach infinity. So from here, you will see minimum is 10, maximum is positive infinity. So we write it as interval notation will be bracket 10, then positive infinity. And for the inequality, it's just minimum, maximum, then less than, put the variable at middle. If you have solid dot, we put equal sign there, otherwise no equal sign. So this one, we put minimum 10 here, maximum positive infinity. X is between the 0 and positive infinity. Open dot, no equal sign. Infinity, no equal sign. So this one is squared bracket, means you have equal sign. So minimum is 1, maximum is 6, x is between these two numbers, squared bracket is equal. You have equal sign here. So the right side is larger, so we put opening to the right side. If we use minimum on the left, maximum on the right, always we use this less than inequality sign. Then on the number line, we have the solid dot because you have equal sign. So we have this number line, then solid dot on 1, solid dot on 6. Because you have equal sign, then it is from minimum to maximum. This is equivalent with this inequality notation. And this is interval notation. So you have 3 different types of notation. Representation. There is inequality notation, interval notation, and the last one is number line. Okay. Then continue to practice. Consider the number lines and write the inequalities that match these solutions on the number line. So this is from -4 to positive infinity. So we write it as inequality. Notation will be minimum, maximum, x between these two, less than, you have solid dot, we put equal sign there. So minimum, maximum. Then we use less than, put a x between the minimum and maximum. So this one, minimum is negative infinity, maximum is 3. Then the x is between the minimum and maximum, less than. Open dot, no equal sign. Then the next one is between the -4 and the +3. You have solid dot, so it will be less than or equal to 3, less than or equal to, then x between them. This one, -4, +3, but this time you don't have a solid dot. It will be no equal sign, x between them. And also if you use the interval notation, it will be equal sign is squared bracket, then maximum is regular bracket. So this one, no equal sign, both regular bracket. Minimum, maximum, then equal sign, you have squared bracket. So this one is -4, minimum, maximum, equal sign, squared bracket. Another side is just regular bracket. So this is inequality notation. Another one is interval notation. And this is a number line representation. So continue. This one you have two piecewise solution. So this one is negative infinity, continue. This is 2, this one is 5, then positive infinity. We write it separately, so negative infinity to 2, less than, then x. And also 5, positive infinity, minimum, maximum for this piece of solution is less than x, less than infinity. So minimum, maximum, we use less than. No equal sign, so it's not solid dot, no equal sign. Or you could write it as a notation. Interval notation is minimum, maximum, no equal sign, just open. And this part is minimum, maximum, then no equal sign, open bracket is a regular bracket. So this one is from -1 to the left and -1 to the right. So you could write it separately. It's negative infinity, -1, open dot, no squared bracket. So it's just regular bracket. You could write it this way, or you could write it as okay, this is a interval notation, or you could write x less than -1, then -1 to positive infinity, xx. So these two are equivalent. Or you could see this solution is all the real numbers except this -1. So you also could write it as x couldn't equal to -1. This is a solution 2. So now we are going to introduce a domain and a range. So domain means the valid input numbers in a relation, we call it domain. So this is corresponding to x, valid x, and the range is a set of output numbers, valid output. So that is y. And if it's hard for you to remember which one is domain, which one is range, just alphabetical order. X first, domain is first. Y is second, then R is alphabetical order, D is at front of R. So independent variable is X. Dependent variable is a variable that depends on the X. So independent input and dependent is output. So in order to write the domain and the range properly, we also want to introduce a number set. So it is same as the development of mathematics. So first the mathematicians found out, introduced the natural number 1, 2, 3, 4, countable number. And after that they found, oh, if I don't have something, then what can I use a number to represent? They introduce a 0. And further they found out, okay, when they borrow something, they don't have that money, then it will be easier to use negative number. So they introduce a negative integer. So they first think countable integers, then at 0 means you don't have it and you borrow, then introduce negative integers. And after that they found out, okay, not only we are going to use integers, if you share something within a family or friends, share a pizza, then you may need to divide it. So they introduce a fraction. Then continue develop the numbers. They found out sometimes not only fractions, but it's a number that you couldn't write it as a fraction, then we call it irrational number. Fractions, we call it rational number. So for the pi, no ending, that is an irrational number. And for the fractions, even if you have no ending, but there is a pattern, so that is still a rational number. If we draw the number set, it's kind of all this one big box is real numbers. In the real numbers we have rational and rational number and irrational number. And in the rational number, some of them they are special. If the denominator is 1, then it is integers. And in the integers, you will have positive and 0 as a whole number. And except the 0, you will have the natural number. So this is all the number set. And most of the time, we are going to just use R, all the integers. We seldom use fractions or rational number or irrational number, because they are hard to separate from rational number, irrational number from rational number. So most of the time, either all real numbers or integers. Integers could be natural number or whole number. So the standard notation for domain and range is this is domain, then equals such that x belongs all real numbers. So this is like the E. X belongs R means all real numbers. Then we put inequality there. So this is a set notation. This is a set notation for domain and range. So we are going to write it in this way. So this one, we are going to find the minimum maximum. So for the x value, it's from the very left to the very right. This is your domain, the valid x input. So this is minimum, the very left point of the function, then all the relation. Yeah, this is the very right side of the graph. That is your max for x. Then we write minimum, then x, then maximum, less than. If solid dot less than or equal to, that is your domain. So we write it in the set notation. So x belongs all real number, then such that minimum is -1, less than or equal to x, less than or equal to the maximum 5. So this is a set notation. And for this one, is function or not, we use a vertical line test. Each time you will see you will have only one point of intersection, so this is a function. Yes. So for the range is for y. So this is for x, this is for y. For the range, we find out the lowest point of the graph and the highest point of the graph. This is a maximum for the y, and this is a minimum for the y. Then we could write it as y belongs all real numbers such that minimum is -2 and the maximum is 1. We put y between them. And because it's solid dot, so less than or equal to, then this is a domain and the range for this graph. So what you are doing, actually, you could think you are drawing a box. So it is a box to enclose the whole graph. So from left to right is your x, from the lowest point to the highest point, that is your y. So this box is your domain and range. So from left to right is domain, from bottom up to the highest point is your range. Then we are going to continue to find the left and the right. So the very left continue is -infinity. The very right continue is positive infinity. So we know that for this one, x belongs all real numbers such that -infinity, positive infinity, the x between these two. And also you could just ignore this inequality, because all real numbers, you could just write it x belongs all real numbers. You don't, if it's -infinity, positive infinity, you don't have to write it out. And also for the functions or not functions, we use vertical line test. Each time only one point of intersection. So it is a function, it's 1x, you have 1y, it's certain. And for the range, we want to draw the minimum. Find the minimum, the lowest point. It will be around 4, or around this one is 4 point something. So it's kind of like 4.4. And for the highest point, it keeps going, so it's positive infinity. Then we have the range. Y belongs all real numbers such that minimum is 4.4, maximum is positive infinity. Then we use less than y. And because the lowest point, no open dot, so it's equal to. So this is for B. Then sometimes the set of data given, ordered pairs given, then we are going to see is a function or not function. We see if the x you have repeat or not. So this one, x value no repeating, we know it is a function. So 1x you have 1y. And for the domain, this time the valid input only 1, 2, 3, 4, 5. You only have 5 x values, you know the output. So the valid input 5 numbers only. For the range, the valid output you have only 2, 3, 6, 7, 8. 5 numbers only. 2, 3, 6, 7, 8. So for a set of ordered pairs of data, you could just list the numbers there. And for this, or you could write it another way is x belongs, this time x is not going to be all real numbers. So x belongs natural numbers, then such that the minimum is 1, maximum is 5, then less than x, less than 5. You have equal sign there, including these 2 points. And for the y value, it will be hard to write because it's not continuous. So you only can write is y belongs natural number, then y equals 2, 3, 6, 7, 8. That is done. So this is a formal set notation. This is just a list the numbers. Okay, so it will be good for you to write it this way. And for this one, use decimals to graph this first, then determine the function is domain and range. So for this one, the vertex is PQ is 1, 3. So we find right one, up 3. This is your vertex, then use a step pattern to sketch it. Then you will see the left, right. It keeps going, so negative infinity to positive infinity is your domain. So x belongs all real numbers, no restrictions. You don't have to write a negative infinity, positive infinity out. And we know that is a quadratic function. So it is a function, it will pass the vertical line test. For the range, it has a turning point. So at turning point, we have a minimum value. The maximum continue will be positive infinity. So we write this set notation out. Y belongs, because the graph is continuous, so all real numbers. Then such that minimum is 3, maximum is positive infinity, then less than less than, so could equal to 3. So this is not x value, it is a y. For domain is y. So y from 3 to positive infinity. Then continue the graph. Domain and range. So these one functions are not use vertical line test, each time only one, but here be careful, you will see it looks like you have this point of intersection, another one is here, but here is open dot, so it doesn't include this point, so you only have one point of intersection. And continue one point of intersection, and after that 0 point of intersection, as long as not more than one point of intersection, this is a function. And here no point of intersection means you don't have valid input, no valid output here, okay? So for the domain, we are going to see the very left and the very right. Here is -5 is your minimum, and the 10, it looks like is 11. This point is around 11. 11 is your max. So for the domain, we could write it as x belongs all real numbers because it's continuous line. Then from minimum to maximum. And this side is open dot, no equal sign. This side you have solid dot, so you have equal sign there. Then this is a domain for this graph. And for the range, you will see you have only 2 y values. So this one is around 2.2 or 2.2, okay? And this one is around between 5 and 7.5, so it will be around 6.1, or just estimate is okay. So for the range, you will see you have 2 y values only, you can just list it. So you could write y belongs real numbers such that y equals 2.2 and 6.1. So it is hard to read the numbers from the graph, so as long as it's from 2.0 to 2.3 or 2.4 is okay. And for the another number, it could be 5.8 to 6 point something, 6.5. So it's human errors. As long as it's close, then it's okay. It's hard to read from the graph. So this one, use a vertical line test. You will see you have 2 points of intersection with the graph. Then it's not a function. For function 1x, you are going to have only 1y. Otherwise, it's not right. So this one you could see is -3, -4. This one, -3, +4. So x repeat, the y is different, so this is not a function. For the domain, we read from the very left is your minimum, and the very right is your maximum for x. So it's -5 to +5. So x belongs all real numbers such that -5 minimum, maximum +5, put x between less than or equal to less than or equal to because no open dot. And for the y, the lowest point is minimum -5. The maximum point is +5. So the range for y is y belongs all real numbers such that minimum -5, maximum +5. Then the y is between these two numbers, less than or equal to. So this is how you find the domain and range. So always write it minimum, maximum, then put x between, y between, then you have the domain and range. So x is for domain, y is for range, and set notation is x belongs all real numbers such that the inequality here, and y belongs all real numbers such that the inequality between. So that is for this lesson, how to determine the domain and the range from a graph or from a set of data. So thanks for watching.